Okay, so today's short little video is on two specific types of linear equations. When you look at these two linear equations, you're going to notice that the horizontal lines are only going to have one variable, and that variable is going to be y. So it's going to be y equals a number. And vertical lines, that's just going to be x equals a number. So Thursday, Friday, we've been graphing linear equations in two variables, and they had sort of a slant to them, whether it would be steeper or less steep, steeper or less steep. Now we're looking at lines that have only one variable. And a lot of people, a lot of kids, find these difficult because it doesn't look as familiar as the other ones that we've been doing. So let's start with the vertical line. If we think about a vertical line, vertical lines are up and down, which could technically be a bit confusing because you're like, wait, this is the y-axis, and if it's vertical, it runs parallel to the y-axis, and that makes you think it should be y equals. But if you think about a vertical line, if you make that traditional xy chart and you say, okay, well, if x equals 6, it means that every single x value is 6. Because x can't equal anything but 6. It tells you x equals 6. So this is kind of like a backwards xy chart, in that when you plug in, you're not really going to get anything out because 6 equals 6. So you can just go ahead and pick any y values you want, as opposed to in the old ones, in the other ones you were picking any x value you want, but x has to be 6. So then you can go, okay, 6, 0, 6, 1, 6, 2, 642. I don't really care. The bottom line is every x coordinate on that vertical line is going to be 6 in this specific case because x equals 6. So when you go to plot all of your points, 6, 0, 6, 1, 6, 2, 6, 3, 6, 642, you're going to have a line where all the points have an x value of 6. And again, if I had a ruler, it would be straight. You draw your line, you put arrows on it, and you label your line x equals 6. Every vertical line, okay, every x equals some number is going to be a vertical line, and it's going to cross the x-axis at that number, comma 0. So in this case, when it's x equals 6, it crosses the x-axis at 6, comma 0, because every x value has to have a coordinate of 6. Now let's look at y equals. Now we can make a traditional xy chart and we can pick our x values, 0, 1, 2, 3. But when you plug in, there's no x to plug in for. There is, it's invisible because it's 0x. But when you plug in, right, you're always going to get negative 5 out for y because y always equals negative 5. And if you want to play the input-output game, if you plug 0 in, 0 times 0 is 0, minus 5 is negative 5. 0 times 1 is 0, minus 5 is negative 5. Some of you may be saying, Miss Almeida, where the heck did this 0x come from? Well, if y equals negative 5, then you can say y equals 0x minus 5 because 0x is just 0, so this term cancels out. You go down to 1, 2, 3, 4, negative 5, 0, negative 5, 1, negative 5, 2, negative 5, 3, negative 5, and you have a nice, pretty horizontal line with arrows, long, where y equals negative 5. Bottom line, vertical lines, x equals a number. Horizontal lines, y equals a number. So it's kind of counterintuitive or against what you would think because y equals lines run parallel to the x-axis. And the reason there is because when you have a horizontal line, every point is going to have a y value of the number you want. 0, negative 5, 1, negative 5, 2, negative 5. And x equals lines or vertical lines are going to run parallel to the y-axis. So it's counterintuitive. It's against what you would think. You would think x equals kind of looks like the x-axis. Y equals kind of looks like the y-axis. That's not the case. Miss Almeida, you're rambling. Yeah, you told me that already. So let's look. X equals negative 8. Miss Almeida, do we have to make those xy charts? No, you don't. Once you get the hang of the fact that x equals negative 8 is a vertical line, all you have to do is say, okay, negative 8. 1, 2, 3, 4, 5, 6, 7, negative 8. Vertical line, arrows, label. Make sure your axes are labeled, and you're done. It's just that easy. Another one. Miss Almeida, y equals 4. Horizontal line, 1, 2, 3, 4. Horizontal line crosses the y-axis, okay, at 0, 4. Label your lines, arrows, label your axes, and you're done. It's just that easy. X equals 3. 1, 2, 3. Vertical line. Label your line. Arrow, arrow, y, x. And if you're drawing your own coordinate planes, you need to make sure that your axis has arrows. It's just that easy. Y equals -1. Horizontal line. Y. -1. Arrows. Y, x, arrow, arrow, label my line. Horizontal. Y equals. Vertical. X equals. So go ahead and try x equals -5. If you don't want to, then don't. Just think about where it would be in your head. Kind of trace it. 1, 2, 3, 4, 5, negative. Arrows. X equals -5. Y, x. So easy. Y equals 3. 1, 2, 3. Line. Y equals 3. Y, x. Arrow, 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 arrow. And then the last two, some of us are going to go, I don't know what x equals 0 is. Well, x equals 0 is the y-axis. If you think about it, if x equals 1 is here, and x equals 2 is here, and x equals 3 is here, x equals -1, x equals -2, it would only make sense that x equals 0 is in between x equals 1 and x equals -1. Very last one and we're done. Y equals 0. Y equals 1. Y equals -1. Y equals 0 is the x-axis. So I don't want you guys to watch this video and then get horizontal and vertical line happy. Just remember that when there's two variables, like y equals x plus 2, you're going to have a line with a slant to it. The only time you're going to be drawing horizontal and vertical lines is when there's single variable equations. Y equals a number, x equals a number, two variables, two variables, two variables, one variable, one variable, two variables, two variables, two variables. Like any sort of slant to it, it's going to be two variables. Horizontal y equals, vertical x equals.